Hello, this is Ahmed, and we're going today to discuss one of the papers. It's an empirical paper, and I would like you to draw your attention to make distinction between theoretical economy versus empirical economics. Theoretical economics is the process of building models to explain to the world economic phenomena. And empirical economics is the process of testing those models to determine how good they are doing in explaining to the world. In other words, the goal of theoretical economics is essentially to build the model that has some testable prediction. And the role of empirical economics is to gather the data and test them using statistical methods. So empirical economics published papers using econometrics or statistical methods to fill the gap between economic theory and observed data. So the paper that we will be talking about is Institution, Politics, and Resource Allocation. The title of the paper is Do Lenders Favor Politically Connected Firms or Rent Provision in an Emergency Financial Market? This paper is by Professor Asim Ejaz, Khwaja, and Atif Mian, and the paper was published in April 2015. So many research papers claims that institution can affect economic outcome. But neither of those papers provide strong evidence on the mechanism behind this causal relationship. So institutions are one of those words which is not very clear as to what it means until you see some examples listed of what institution might be in this context. But for many economists, once you read about institution and their potential effect on economic outcomes, one might become convinced that they can be very important in driving a lots of things that happens in economic outcome of a society. So there are a number of researchers who believe that institution is perhaps the primary driver of economic outcome, differences across countries. But the problem is that most of these papers present evidence that there is causal relationship between institution and economic development. But they fail to prove why. And what brings us from institution on one hand to the strength of economy on the other hand? Why is there a causal relationship? So politics and resource allocation. So Khwaja and Mian attempts to demonstrate the existence and magnitude of economic rents from political power in Pakistan. And what they do is that they look at Pakistan and they are looking for how political power in that country translates to economic rent. To do so, they have or they use a very powerful weapons. And that is that they have access to a data. They acquire a data set with information on every outstanding corporate loans in Pakistan from 1996 to 2002. That includes the names of directors, names of director of borrowing firms. What they have in their paper and what most researchers think is a great equalizer across economists everywhere in the world, and that is to have these great weapons in their disposal to utilize, and that is that they have this great data. Khwaja and Mian had something that maybe most of us, something that not all of us have, which is the connection to get the data on every corporate loans in Pakistan. And that was outstanding over the course of 7 years from 1996 to 2002. Includes who were the borrowing firms director. And this is the kind of data set that you're going to get only through connection. So to this, they add information on names of politician running in a national or a state election, allowing them to identify asymmetries in lending to firm associated with politician. The question is, why is their data so amazing? Because if you know something about every loan, so the reason that their data is so amazing is because if you know something about every loan in Pakistan and you can tie that to a set of individuals that are associated with firms, as the authors said, directors are often also owner of these firms in Pakistan. And then you are able to make the comparison that tells you something about how the process of those loans being undertaken. In particularly here, the authors are looking for corruption in that process. All that is left for the authors once they have the data set is to figure out the right measures, the right comparisons to make, and run those regression. They need one more thing. If they want to think about politics and corruption in Pakistan, they want to know who is involved in politics of the people, who are the names of those names in those data sets. So they actually take much easier to acquire data set and match the two together. The other data set they have is all the names of politicians who runs in either the Pakistani's national level or the state or provincial level. As you know, there are 4 provinces in Pakistan: Punjab, Sindh, Khyber Pakhtunkhwa, and Balochistan. And that allows them to identify firms that are politically connected in a sense that the director is a politician and firms that are not. So what do we want to know about lending? To do that, we can look at it in a following 2 dimensions. One key dimension on which politicians might differ in their access to lending, the questions we need to ask is, can they borrow more than non-politician? That is the key question. And a second key dimension is that they might face a lower loan price. So what measure did they want to use? Here we should think about access to lending, and there is market for loans. This market might be far from perfect, but let's still think if it as a market, and market in equilibrium are going to have a price and quantity. We can think of loans in the same way. Politician, if there is some kind of a corruption that give advantages to the politician in the system of lending, might get lower prices. Or they might get higher quantities. And in developing countries, the market for loans is generally quite constrained, characterized by some rationing, so the higher quantity is the advantage too. And that is what the author is going to look at. They are going to look for both quantity and price. Please do not, please note and do not forget that this is not entirely captured by only looking at the interest rate. Now, loan, the interest rate is RIJ. Now, loan price to you might translate to be the interest rate, and you might think that the interest rate is the price of the loan, but that is not the case. Why? Take a look here. The loan price is not entirely captured by looking at the interest rate, which is this portion. Instead, the authors use total payment made by firms per rupee borrowed from the bank's perspective, the loan's rate of a return. So what is the loan price? This question tells us something more than the interest rate, as I said, 1 plus RJ, IJ. This is the interest rate. Interest rate per period. What else in the loan price other than the interest rate? What else is there in that equation? Is the default rate. So what is the default rate? The default rate is the inability to pay the loan back. Simply, you just don't pay the loan for whatever reason. The default rate is relevant because if the bank does not get the loan, let's say you haven't paid any interest and you did not pay the loan, so what would be the price of the loan to you? It's zero. So that are the key elements of the price. In places where default is possible, when it comes to loan price, or as the authors mention, if you look from the bank's perspective, the rate of a return, you do not only think about the interest rate for the loan that are paid back, that share of the loan, but you think about this part. And that is the default rate. The delta is the default rate that actually comes back and you get the loan. So the loan amount plus the interest rate. Or you pay the amount as borrower. If you don't pay the loan back, you pay either nothing or you might pay only part of it back. So the bank somehow might be able to get some of the money back. You can call that a recovery rate, which is here. That's a recovery rate. So the amount return is going to be anything from 0 to whatever you can get, and that is this term right here. And this part. And for non-defaulted loans, you have to pay the interest rate as usual, interest rate. But if you default on the loan as borrowers, then this term, whatever bank can get from you, so the author is going to look at the default rate as the full expression. Now, they are going to use 4 strategies. And these 4 empirical strategies, and we are going to discuss these regressions and the way they have been presented. So the first empirical strategy is that the authors first compare loan made to firms with a politician among its directors to loan made to other firms. To do so, they eliminated time variation from their panel data set, creating a cross-sectional of lending data at the firm bank level. What do we mean? Cross-sectional data analysis is when you analyze a data set at a fixed point in time. Surveys and government records are some common source of cross-sectional data, and the data set record observation of a multiple variable at a particular point in time. Financial analysts may, for example, want to compare the financial position of two companies at a specific point in time. And the way they do it, they will compare the two companies' balance sheet. Now, going back to the regression. So the regression specification we have, first, they are going to look into firms with a politician among its directors or compared to all other firms. In the regression equation, the dummy variable, which is political I, is going to keep cropping out. I is the firm's dimension in the index. So political I is going to be a dummy variable. If it's 1, means that the firm has a politician as it's one of the director, and 0 otherwise. So beta 1 here would be a variable of interest. They want to know the result of that comparison. What they are going to do is that they have actually a panel data set. They have firm loan throughout 7-year period. But to simplify at this stage, they are going to crunch their data set down. So all they get is a number for each firm and a bank. So if you are a firm borrowing from 10 different banks over the period, even if you have 100 different loans, there will be 10 observations left. It is the total amount firm can borrow and price they pay for each bank from the perspective of the firm. So this is where I is the firm and J is the bank. All the variation is at that level. Alpha J is the bank fixed effect. What is that allowing us to do is to compare. The rule of thumb is that whenever you use fixed effects, you're comparing within that entity. Here, we are writing fixed effects for each bank. So we are essentially going to control for characteristics of each bank. And we are just comparing within each bank, its lending to different firms. Within each bank, this alpha J, we are comparing lending to political and non-political firms, and the authors are going to control for something that are firm specific. Is the firm specific, and something that are bank specific. And this is our error term. The result, when they run this regression, the result is this table. Table 3 in the paper. So this table tells us about the preferential treatment of politically connected firms. What are the main things we learn from this table? The log loan size, which is this number, this is proportional indeed. It is a large number and does not translate to 37%. Once we get a big, then it becomes approximation. Loan size for politically connected firms, even within the same bank, is bigger. Looking within the same bank loan, politically connected firms on average get bigger pot of the loan. And this is not loan by loan. This is a loan for each case over the period of study for each case. This is the same time the price of those loans is lower. So the rate of a return from the perspective of banks, the lower rate of a return means lower loan price. The default rate finding is not different finding, which is column 3 to 5, from column 3 to 5, which breaks down the loan price into other pieces. The default rate is part of loan prices, and that is because if fully defaulted with no recovery by the bank, you get the loan essentially for free. That is significantly higher. That is going to drive down loan prices. Breaking down loan prices into these three pieces among them, default rate is big. What happened politically connected firms getting cheaper loans on average, and that seems to be driving, that which seems to be driven by massive differences in the default rate. Remember, the brief review for those of you who are less experienced in going through tables, each of these columns represents one regression, and that is the standard, not universal. There are 5 different regression, and this is one of those papers that they do not use stars to represent statistical significance. So you want to compare the estimated coefficient to the standard error. So when we say that the log loan size is bigger, we are confirming in our head, trying to see if you feel that multiplying by 2, the standard error, you will get a number for the coefficient that as large as or big, then you have statistically significant coefficient. Why do we multiply by 2? Because as we know that the t-statistics is the coefficient divided by the standard error. And a good rule of thumb is that if the t-statistic is 2 or more, that is going to be statistically significant. Now look at column 1. In column 1, we have 0.37, and that is statistically, by looking at it, statistically significant, different in quantity, statistically significant different in rate of a return, statistically significant difference in default rate. Conditional on default recovery rate is not different, and actually the interest rate by politically connected firm is on the margin of statistical significance and higher. Now look at this observation. Why is this observation different? Looking at this observation, you would know what is going on. They know that the loan size, I mean all loans, what they don't know is that in every other case is the interest rate. Let's say for column 5. They only know the interest rate for 89,223 firms. If they don't know the interest rate, then they don't know the rate of a return. They know whether firm defaulted or not. But what they don't know for a firm that they didn't default is what the recovery rate was. If they would defaulted, how much the bank would have gotten back. This tells you that the only 24,562 of those loans actually defaulted. And this is how we would measure how much of that loan was recovered. So we have for control, we have all these yes, no's, yes, no, yes, 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 yes. So what does that mean? Yes and no in regression table is used for some specification and have some elements and some don't. Here, we will see all yeses for controls in general. You see all yeses here in control. In general, the authors want to include controls, meaning these additional controls variable in all their specification, and they are going to show you something, sometime with a specification and sometime without specification. So the reason is to signal to the reader that control variables are included or excluded from the regression. So this basically, yes, means that the reason is that they are trying to signal to the readers that control variables are included, which is in this case, yes, or excluded, and if there was no from the regression. You can critique this table as the authors do. The authors are comparing, admittedly within the same bank, politically connected firms and unconnected firms. So politically connected firms are those have a director who is a politician, someone who runs in a national or a state election, and that is what exactly we want to know. If these politically connected firms are giving preferential treatment, once we see these results, we have to start thinking about what possible omitted variable might be. Anything a characteristics of bank, because all the characteristics of bank have been counted for. If there is a bank fixed effect, you control for everything about bank. It is not specific characteristics of bank that can be a problem here. However, while the authors have some controls for each firms, something is going to be potentially hard to control for, as the authors have admitted. Let's say there is some firms that are just seen as kind of promising. But the kind of firms, yet the politician as a director, are the same kind of firms that the banks want to lend to. Both are attracted to the firms, and they are kind of a glamorous in a sense, but they are promising in some way. Often the most promising firms are the ones with the highest risks tend to crash. Why not an explanation? So the most promising firms attracts banks and attracts influential people like the politician to invest. And those firms are also the riskiest. They get bigger loan, but they tend to default more. It does not seem crazy, but to explain the result without corruption at all. The problem here is that firms' characteristics might be both correlated with politically connectedness and independently affect the outcome variables. In other words, there be error terms and correlation with the key right-hand side variable. And that would be omitted variable bias. Now, omitted variable bias occurs when a relevant explanatory variable is not included in a regression model, which can cause the coefficient of one or more explanatory variable in the model to be biased. An omitted variable is often left out of a regression model for one of the two following reasons. Number one, data for the variable is simply not available. Two, the effect of the explanatory variable on the response variable is unknown. So in order for the omitted variable to actually bias the coefficient in the model, the following two requirements must be met. Number one, the omitted variable must be correlated with one or more explanatory variable in the model. And two, the omitted variable must be correlated with the response variable in the model. So that is the for omitted variable, But in brief, you might not believe that there is no omitted variable bias, but you should worry, in this case, about omitted variable bias. This brings us to an empirical strategy number 2 that the authors are using. The authors next use the same data set, but what they do is that they adopt a difference in different strategy, meaning diff, using bank type as the second differences. The idea is that a private bank should be less likely than a government bank to engage in a politically motivated loans. And the authors argue that this is because government banks do not have hard budget constraint and their top managers are politically appointed. If you think that there could be firm level characteristics that are potentially correlated with political connectedness, in the error terms need a new strategy. So what the authors is going to do is a classical things which we call difference in difference strategy. The second difference here, where the first was politically connected or not at the firm's level, the second difference is going to be the bank type. They are going to compare two types of banks: privately owned banks that are presumably driven by a profit motive, and government bank, which is in Pakistan, institutional setups work as follows. Their top managers are appointed by politicians, and the bank themselves does not have hard budget constraint. What does that mean? Meaning, if they run out of money, they don't die. They imagine they will get more money if this scenario happens. So government banks, what is called, have a soft budget constraint, and they are in a situation where they can potentially be bailed out with a higher probability. So the authors are going to compare government bank loans to private bank loans. And why would they do that? If private banks are driven by profit motives, that is not what you expect corruption to be concentrated. If you see government banks behave systematically favorably towards politically connected firms relative to unconnected firms compared to private banks, then you're probably going to suspect corruption. In that sense, this is very convincing strategy. They are going to look at the bank and compare government and private bank. In order to do that, they estimate the following two regression specification, which is 3 and 4. They are going to run two difference in depth or two different depth or two difference in difference regression specification. And the first one, which is number 3, has a dummy for beta 1 politics, like here. That's a dummy. And it has the interaction terms with it, which is this one. So beta is going to be the effect of interest, but instead of controlling for a bank, whether it is private or government, they go further and add bank fixed effect, which is this one. That's a bank fixed effect. And they add this bank fixed effect within the same bank, and we are going to compare politically connected and unconnected firms. Then we are going to compare if the effect is big, if the effect is bigger for government banks or private banks. And this brings us to the result of the table, table 4. According to Professor Jason Jarrett, Ottawa, he loved this table, and he always said that this is a great table for teaching. So the authors break this down. The regression we just introduced is reported in column 5. You can see that the interaction, which is politically connected, and the government has the coefficient of 9.91. This is the interaction term, and that has the coefficient of 9. The question is, where does this 9.91 come from? So the authors have constructed by running separate regression for government banks and private banks. If you look at in table 3, we saw that the default rate was about 6%. It's right here. Default rate was about 6%. And this is 6% point higher for politically connected firms. Now, the authors run the regression separately for government banks and private banks, and that is in column 2 and 4. Column 2 and 4. 2 and 4 of this table. So in column 2, you see that the coefficient on politically connectedness is 9.13. And that is with the bank fixed effect and the controls. And the controls we had before, this is the regression from before for government banks only. For government banks only, the coefficient was 6.22. And now in table 4, it's 9.13. It's right here. When you restrict to a private bank in the sample, that coefficient is minus 0.78. So the question here is, diff and diff specification in table 4, which is this table, the coefficient on interaction term, and when you run diff and diff, where does the 9.91 comes from? This comes from column 2, 9.13, which is the bank fixed effect and controls, that tells you that politically connected banks has a 9 percentage point higher default rate at government banks without any comparison. It's right here. And in column 4, is telling us that politically connected firms have 0.78 percentage point smaller default rate at private bank. Not any comparison across banks compared to politically or unconnected firms. So politically connected firms compared to unconnected firms have 9.13 percentage point higher default rate at the government bank and 0.78 smaller default rate at private bank. The difference between these two gives us 9.91. So when we take the difference, so we get 9.13 minus 7.07 minus 78 is 0.78. And that is giving you 9.13 plus 0.78, and that is going to give us 9.91. So the difference between those gave us 9.91. Relative to private banks, government banks have higher default rates of politically connected firms compared to unconnected firms by 9.91 percentage point. The default rate, a politically connected firm, is 9.91 PPP, which is percentage point, higher relative to unconnected firms at the government banks relative to private bank. So that is not the only way to run diff and diff. We already see two ways running diff and diff. What we need in diff and diff is to have at the very least, B1 political and interaction term. And this two dimension control for an interaction term, you can instead substitute fixed effect if you want. In the second specification, they run, instead of having political firms versus non-political firms, they have firms for fixed effects. So that means that they control within every firms, and it is within firms and within bank comparison. That is very powerful. And this kind of specification is very popular. To have diff and diff with two dimension fixed effects separately, and here firm and bank. And you will see the result reported in column 6 of this table right here. And that is 1.4. Now, before we go there, why the observation in column 5 of this table goes down from 112,685 to column 6 of the table to 18,000. From this number, it goes down to this number. When we add fixed effects, when we add a firm fixed effects. So the question is why? If we add firm fixed effect, that means that we are comparing within same firms for private and a government bank's loan. But if you're comparing within the same firm for a private and a government bank's loan, that means that the same firms must have borrowed from both private and government banks. It turns out that only 18,819 right here, subset of this sample borrowed from both sets of the banks. So what does it mean? We see a big effect, 9.91 in column 5 and no effect in column 6, which is 1.4. So let us start with column 6. That means if you borrow from both government and private banks as firm, your default rate not significantly different between the two. A firm's default rate not significantly different from government and private banks, whether it's politically connected or not. That is the key dimension. So politically connected firms that borrow from both banks have no higher default rate at government versus private banks compared to unconnected firms. So again, where 9.91 did came from, right here in column 5, table 4. This column 5, which is 9.91, if it is not due to the fact that the same firm has higher default rate at the government banks, it must be there due to the fact that the different firms tend to borrow from government and a private bank. In other words, if only a small population or small proportion of 18,819 firms of borrowing from both government and private banks during that sample period, most firms therefore only borrow from government banks or only borrow from a private banks. So it is these firms that can't even get loan from a private banks that are driving the default rate effect. So politically connected firms default relatively more from government banks compared to unconnected firms relative to private banks. That is because the private banks aren't even giving those firms the loan that they know probably that those firms would default on. And this effect must be driven by the firms only borrowing from one bank type. Just column 6, that's 1.4. Borrowing from both, we don't see it here. So this is a very useful table. As Professor Jason always say, diff and diff is a hugely important strategy because it's actually probably the easiest strategy to find as a possibility for many kinds of research questions. Here, the nice thing is that you see that the two pieces of strategy, column 2 and column 4, column 2 and column 4 gave us column 5. Again, as we said here. So the other thing you see is that this choice of whether or not to include fixed effect changes interpretation somewhat. But the nice things about column 5 versus column 6, in terms of your understanding of what it means to write down a regression equation that is a diff and diff equation and choose whether or not to use fixed effects or just dummies. So the interpretation there can be different in your sample, also be different. That is a very context specific. So now this brings us to strategy number 3. So the authors, Hoja Mian, next they compresses their data set to the firm's bank type level, where bank type is government or private, and drop firms who only borrows from one type. They do this so as to compare firms' total borrowing from each type of the bank. The authors are going to further simplify the data set in order to study the different variable, which is loan size. We just studied the default rate, which was what was driving the loan price. Now they are looking at the quantity. What authors are going to do is stick to the same diff and diff strategy involving within firm comparison. And what we saw in column 6, table 4, was within firms comparison. And there is no effect within firm on loan prices. That is all across firms who borrow either from private or a government bank. But the authors are going to stick with it anyways. So we are going to see in a regression equation, we have alpha j, that is firm fixed effects, are now in here and it's going to stay. So loan size, they are again going to compare government and private banks. And they wanted to know if you are going to get a bigger loan from a government or a private bank in total. So each firm now has 2 observations. The total of all loans made by government banks to that firm and the total of all of the firm's loan from private bank. So they are going to shrink the data even more, and they are not going to have each bank and each firm. They are now going to have each bank type and each firm, which is J. So J is going to be the bank type. J is going to be the bank type. So you're going to add up all the loans each bank gets from government banks and all the loans each firm gets from the private bank. So loan size I and J is either government or private. The reason for that is simply if you want to know total borrowing and use that as an outcome, you probably want to know total borrowing from each bank type here. Not just each bank. You don't have to worry about the fact like that 10 private banks for each government bank and vice versa. So this is simplifies the attack of the question. So summarize again, each firm, you're going to see the total of all loans by government banks to that firms and the total of all loans by private banks to that firms. In other words, the total of all of the firm's loan from private bank. For the regression specification, the regression specification is going to be firm fixed effect and bank type fixed effect and the interaction terms. Where in this regression equation is the bank type fixed effect? We have two types of bank, government and private. For two dimensions, we need only one fixed effect. What are the two cases? Government and private, and what happened now? We don't want to sort of see this as a specification of this dummy variable, since we have two specifications for beta, two in the government, which is already represent information as fixed effect would. So fixed effects, you have for every category a possible number, and that number for firm, we call it alpha I, but we always drop one, like dummy variable. You drop one category. If there are only two categories, you only need one fixed effect or dummy, and that is going to be the government J. So this government J, gov J, is a dummy variable. 1 if it is in a government bank, 0 if it's a private bank. So you should think of these still fixed effect by bank type and fixed effect by a firm type. So this brings us to the result of the table, and the table is table number 5. So here we're going to ignore column 2 and column 3, and we are going to focus on column 1 right here, which is the analog of what we had before in column 6. Column 6 of previous table used firms, fixed effect. It had more observation because it was by firm bank, not by firm bank type. But still, the same set of firms had 10,880, but now we compressed it to government banks versus private banks in total. And now there is a positive and significant effect. Relative to private bank, politically connected firms versus unconnected firms get bigger loan of 0.29 in total from government bank. So in terms of quantity, the diff and diff estimate is positive and statistically significant. Even though within the same firm, we are not seeing higher default rate, but in diff and diff, we are seeing a bigger loan size. So the column 1 is the diff and diff estimates with the firm fixed effect analog to the loan price in column 6 of table 4, right here, with this one. So there is no price effect with or within firms, but there is a quantity effect. So the main estimate of interest is 0.29, which shows that the difference between politically connected and politically unconnected loan quantity is 29% bigger for government banks versus private banks. To the authors, 0.07 is not estimate of interest in terms of causal identification. But still, notably for what it means is 0.07 is the interaction with politically connected government banks. 0.07 refers to unconnected firms are still getting larger loans from government bank versus private bank. But the politically connected firms are getting even larger differential in loan size between government banks and private banks. This is the difference in difference. And let us focus on 0.29 estimates, which is this number or this result. We want to think about 0.29 now. Whenever you run a regression, you can use an interaction term if you want to study heterogeneity, treatment effect. That does not mean it has to be in def and def. If you want to study whether something is bigger in some cases than others, you can add an interaction term. And that is what we are going to do. Look at in the next table, which is the authors are going to add a third layer of interaction. Sometimes that is called triple def or DDD. Difference in difference in difference. But here we are not going to talk about this in this way. Just think of it as a following. Let us take this point 0.29 and see whether we can see some heterogeneity effect by the type of political connections. We have already established here that the politically connected firms get bigger loans relative to unconnected firms from government banks versus private banks. Who is driving that? In table 4, the authors take baseline result and added this percentage vote: win, victory, margin, win, and a party. Right here. This is what they add. A measure of how strong the politician in charge of these firms are. If the politician got more votes in the election in which he or she runs, the effect is, looking at the next table, is 0.69. It's right here. If a politician got more votes in the election in which he or she runs, the effect is 0.69, even bigger. If the politician won instead of lost in the election, they run, the effect is even bigger, and that is 0.63. If the politician victory margin was larger, the effect is even bigger, 0.53. If their party won the election, the effect was even bigger. If more people participated in voting, the effect was smaller by 0.1%. So the effect was bigger in places like local voting was quite apathetic. I mean, a citizen who does not vote in a public election is an example of a apathetic citizen. So the first four columns are all about political strengths. 1, 2, 3, 4. These are about political strength. Now the question is, why do the authors include electoral participation in table 5? This comes back to the literature on corruption. One widely studied component of corruption in election system is that it is easier to fix an election and it is easier essentially to manipulate an election when there is a low participation rate. So low participation is potentially interesting for the authors to study because they think that elections where the local area which the politician is working had low participation and more likely to be the areas where the electoral system is affected by corruption. That is the inspiration for that, and that is why you should not be surprised by this negative number. Places with low number of participation are the election that often easily fixed in the literature. So in this table, why the authors did not use an entire sample of 11,685, which we saw in other tables. The more you control for, the more convincing it is. Within the same firm as you can, with the firm's fixed effect, this happened. It is going to be more convincing because you are controlling everything about that firm when you impose firm effect on a regression. Whereas you only compare to whether firm politically connected or not. You're controlling for something that is crucial for the study because you are still controlling for the difference between connected and unconnected firms in general. So firms' fixed effects are stronger. In a sense, you are controlling for each firm's and characteristics. All it is left in terms of variation after you control for firm's characteristics and bank characteristic is to look within each bank type and each firm. Any variation you get is more convincingly assigned to this idea, to this corruption. It is not something special about this firm in question, but it is that the government bank treat them differently. And in table 5, they treat them even more differently, depending on how powerful the politician are. So this brings us to strategy number 4. Finally, the authors restore time series variation in their firm bank type data. And they also restrict the data set only to politically connected firms whose politician or their parties won or lost power via an election during the period studied. So this allows for the following specification, which is right here. The authors are going to go back to the original data set in a sense that they are going to remember that they have information on loans over time. They are going to add T as an index to their regression and take each year of loans separately. So they are still not going to do each individual banks. They are going to talk bank types, so it is going to be by firm, government or a private banks in total and the year. So the typical observation would be a firm, and the firm that got this much money from private bank, and let's say in a particular year, 2002, 2001, 2003. And that is the kind of observation they are going to use now. And what is really nice here is that they can look before and after the politician involved in a firm after they won the election or won power in the party of that politician. So that is before and after comparison that could potentially be very interesting. That means that you have to restrict the data set, and you need only politically connected firms because those are the only ones with the politician. All the unconnected firms are out of the data set now because they don't have politician. So it is only politically connected firms, and you're only going to look at the politician who either won or lost power in an election during period that, or those whose party lost or won election. So it is people who both were out and then won an election, or people who were in and lost an election, or the same thing with respect to the party of that politician. So this is really nice. So the beta 2 win by politician I in time t. You win if you oppose winning an election that is either 0 at the beginning of the sample and 1 later election if you won election in the middle, or 1 at the beginning, 0 later when lost an election when you were already in power. So the principle of this idea is to compare before and after winning power. What do we want to control for? Then we want to control for everything, but that before and after. And this is this fixed effect. A fixed effect for each firm bank type. So you're going to take, for example, firms is borrowing from a government bank and have a fixed effect for that, and firm A borrowing from a private bank and have a fixed effect for that. So you want to do that because you only want to look for before versus after, and you want to compare before, after for government banks and before after for a private banks for politicians who win the election, and that is this term, the interaction term. Interaction term or the key. The key is winning. The key is winning, which is this term, times borrowing from government bank. So the key term is this one, times winning from the government bank, or winning times borrowing from government bank. Do you move up borrowing from government banks after you win an election? Let us find out. And that brings us to this nice table. The effects are pretty interesting. Essentially, let's focus on column 1. Column 1 right here. And column 2. Column 3 and 4 just show when you combine the party and the individual things, and let us not worry about it for now. But column 1 and 2, the coefficient of minus 0.120 shows that the level of effect for private banks and coefficient of 1.08 shows the level of effect for government banks. Interacted, and this is going to be the different depth. So let us go over this once again. Loan size again is the dependent variable here. Loan size is the dependent variable. Once you win an election, or more general, when you are in power, because this involves people who lost election. When you are in power, you borrow more from government bank, which is this, relative to private bank. You see the effect is negative here, this effect is positive. Compare to when you're not in power. Think about the different diff here. When you are in power versus not in power, you borrow more from government bank, which is this, versus private bank, and you move into government bank when you move to power. What happens to your borrowing from private bank coefficient? You move into government bank when you move to power. So what happened to your borrowing from a private bank coefficient? Bingo. Minus 0.120 represents in power. And in power, government bank, both are dummy-variable, but in power of government bank is interacted with the government bank, so their coefficient must represent 0.186, the diff and diff, and the private, which is minus 0.120, bank before versus after. So you borrow less, minus 0.120 from private bank after you are in power, compared to before, and you borrow relatively more, which is 0.186 from government banks compared to private banks. And this is really strong indicative or indication of corruption. When you are in power, you actually substitute from private bank to government bank because the coefficient of minus 0.120 is negative and the diff and diff coefficient is positive, which is substitution effect. And the same is true instead of looking at the politician themselves. If you look at the party of politician, that is minus 0.12. And minus 0. It's not minus, but it's 0.17, the same effect. So let us talk about the identification strategy itself and its implication. And going back to the content and answer the question, how does this affects development? Let us review instrumental variable. When we saw instrumental variable last time, we had the assumption, and we talk about it very carefully, so the exclusion restriction. That is the assumption that is the one that the strategy depends on. What is in diff and diff strategy depends on. Let us go back to the origin of diff and diff strategy. Let us simplify this by talking only about the initial set of results where diff and diff was a government versus private bank and politically versus unconnected. What is the identification assumption? So, what is the identification assumption here? You control for everything to do with firms, and you control with everything to do with banks. So if there are some omitted variable, it has to be vary by both the firms and the bank dimension. In the second empirical strategy, beta 2 politically and the interaction terms times the gov j is the key repressor. You want to make sure that there is nothing in the error term that is correlated with this. If there is something in the error term that is correlated with this, it must be two-dimensional. And that is correlated with both politically connected connection and the bank type. government or private. Otherwise, it wouldn't be correlated with this type of two-dimensional variable. And that is what the authors state in their paper, that the identification assumption is that there is no omitted factors or no omitted variables that vary both by politically connectedness and private versus government bank, or private versus government banks. That is why diff and def strategy is nice if there is no omitted variable to screw you up. So it has to be something that varies on both dimensions at the same time. So def and def strategies are still widely used, including in development economics, where people are particularly strict about causal identification, because this, I think, is that the kind of identification assumption that you can or more easily argue for than IV. So identification assumptions are really important. Now, this brings us to something else, and that will bring us to an alternative explanation of social lending. For the authors, the different def strategy, the identification assumption is that there are no omitted factors that vary with both political connectedness and bank type. But what if the following story holds? Some projects have high social returns, but low private returns. And it is politically connected firms that are more likely to engage in these. So government banks, valuation of such project is higher than that of a private banks. So in this case, the result could reflect the presence of such social lending. Just to summarize, the identification assumption in this paper is that there are no omitted variables that vary within politically connectedness and bank type. The authors think the authors take a section to think about the omitted variable. And the problem is that there is a potential omitted variable problem that is actually, for those who know the context of developing country lending, somewhat it's obvious to them. This requires us to give a background to or on what you often see on developing countries. For example, in India, China, Brazil, and these other developing countries, there is all these banks such as the development bank, the agriculture bank, that are historically geared towards particular sectors and trying to support that. The same is true in Pakistan. There is the social bank, where the bank are trying to invest in firms that are doing works that is good for society somehow. So it is possible that what is happening instead of a corruption is the following. What the authors called social lending, let's say a project or a firm has a high social returns and low private return. It is not profitable for the firms, but it is good for everyone in the society. That is exactly the types of projects you expect that the social banks to invest in. Maybe the government banks are just these kind of banks, and maybe government banks value socially useful projects, and the firms that undertaking socially useful projects are exactly those ones that are politically connected. Politicians are just good people who are investing in socially useful firms, and government banks are just good banks that are trying to encourage socially useful projects. Questionable, but possible. This could be the explanation for their results. That would be the omitted variable. Why this would be the alternative explanation for the author's result for the omitted variable bias problem, social lending? does not explain that. Social lending does not explain this. Essentially, this is the way it works. With an identification assumption, you're trying to sort of argue for something. You cannot prove an assumption, you have to argue for it. If you present your work to other economists, this is how the conversation goes. You say, look, here is my paper, and here is my identification assumption. But somebody says that, okay, what about social lending? The author is going to say, look, you might think social lending means some project which has high social returns, and they should also have a high private returns. See, a huge default rate. T is a huge default rate in those projects. So this argument is in the favor of the author. There is another way if you confronted with the counter argument to your assumption. You can't show it directly that your assumption is true, but for those of you who are going to the research, then you have to argue for it. And that is what the author is going to do here. They are going to provide indirect support for their assumption of identification by showing that this argument looks dubious, not clear, not obvious, equivocal, questionable, and doubtful. Some researchers has one way of dealing with kinds of a problem. Shoot it down through logic and knowledge of the context, or the other way is here. Use the number to see if the argument is credible or not. And that brings us to this table. Evidence against social lending. The number are the following. Some government banks are social and government banks, and the numbers are as following. So some government banks are social and government banks are not. Some of them are not. If this was all social lending, you would expect that the social government banks to be the ones that are responsible for the full effect. Remember that the two effects that matters is column 5 with the default rate that the coefficient, which was in table 5, the default rate that the coefficient was 9.91, if you remember. So we'd expect that the 9.91 to be driven by social government banks. What the authors do is they look at the heterogeneity again by adding another dimension of interaction. And this time, they divide government banking into non-social and social banks. And actually, the results are exactly the opposite from what the social lending explanation would suggest. Social government banks are by no means with a coefficient of minus 9.4 responsible for the 9.91 if you interact with social government banks that effects are much smaller, minus 9.4. In fact, it is completely wiped out. The default rate effect is driven by non-government banks, 10.74. This coefficient is the difference for non-social government banks, and minus 9.04 is the relative for a social government bank versus government bank's effect. So a social government bank has a smaller effect. And the same is true for column 2, fixed effect. So the fixed effect regression for log loan size, this effect is actually, again, the opposite from what you would expect if social lending explanation hold. Social government banks have minus 0.22 def and def coefficient than ordinary government bank, which is 0.36. This is not showing that the social government banks are lending to good projects and losing all their money in a default. That is not the case. It is the opposite. It is the non-social government banks that are driving the effect. All the authors did was to split up the data set into two pieces and use another interaction terms, figuring this out. Column 3 and 4 are just another way of seeing whether social lending is the social lending argument holds, which is not. Now, how costly is political lending in Pakistan? Khwaja and Mian quantify two costs of political lending, and they do the deadweight loss from extra taxation required to bail out government banks. The estimated magnitude is 0.16 to 0.3% of GDP per year. And losses from non-investment of a defaulted credit, estimated magnitude is 0.8% to 1.6% of GDP per year. Now let us quantify what this means for development. So let us come back to this. The whole paper is about trying to see whether we can see corruption in the lending center that are tied to political power in Pakistan. And it does look like, in a comparison of a government and a private bank and politically connected and unconnected firm, politically connected firms are getting more generous treatment from banks who are in a position to give in that treatment. So it looks like that the corruption, and that's what Khwaja and Mian trying to argue here. And an institutional backdrop to that is bank work in Pakistan, which is discussed very carefully in the paper here and there. We think that the paper is kind of nice for explaining the context, and that is why we are comparing this with the institutional paper. And therefore, we will stop here, and hopefully we will pick up another paper next time. Until then, I will let you go and take care.